The entire first semester of pre-calculus deals mostly with 5 types of basic functions. Actually, there are only 2 types of basic functions, but we'll see that later. There are power functions, exponential functions, and then inverses. And I don't include linear functions in the 5 most basic, because linear functions is really something that's preliminary to pre-calculus, something that we simply assume everybody understands. Okay, so the 5 most basic functions are the basic quadratic function, y equals x squared. Many things are modeled by quadratic functions. And this is the basic quadratic function. Okay? You have the basic exponential function, y equals 2 raised to the x power. And you have the basic reciprocal function, y equals 1 over x. Now there are 2 more, basic cubing function and the basic reciprocal square function. We'll list those shortly. But what we want to do is we want to look at these functions and see how to evaluate them. And we're not evaluating things with a calculator. In my pre-calculus course, calculator is illegal up to at least midterm. Okay? No calculator. We need to understand these functions by being able to understand the arithmetic that we use to create their graphs and then to manipulate the graphs. Okay, and we start with the graphs of the basic functions, which cover a whole lot of what we do in pre-calculus. Depending on what you mean by cover, practically all. Okay, so anyhow, here we have the 3 functions. Now, we evaluate the functions at the standard basic points. Standard basic x values are in the set -2, -1, 1/2, 0, 1/2, 1, and 2. Except that we leave out any x value at which we can't evaluate the function by simple arithmetic, or at which the function perhaps is undefined. Now, I'm not using all the words I could use here. I'm just going to say where possible, and I'll specify what where possible means. So I want to make a table for the x squared function. So we have x, and we have y equals x squared. And the x values are -2, -1, -1/2, 0, 1/2, 1, and 2. Okay, well, we want to list the y value over here, and y equals x squared. So means the y value here would be the square of -2. And that would be what? Square of -2 is 4. Because, I'll write it out here, -2 times -2 equals +4. Negative times a negative is positive. 2 times 2 is 4. Negative 1 squared gives you 1. Negative 1/2 squared, well, negative 1/2 times negative 1/2 is 1 times 1 over negative 2 times negative 2, and that's positive 1/4. So we get 1/4. 0 squared, well, 0 times any number is 0. If you have 0 of something, you don't have anything except 0. Okay, so we have 0. And at 1/2 we get 1/4. At 1 we get 1, and at 2 we get 4, and that should all be pretty obvious. Okay, so there's our x squared function. Okay, now our 2 to the x function. So let's just list x and y equals 2 raised to the x. Okay, our x values are, again, negative 2, negative 1, negative 1/2, 0, 1/2, 1, and 2. Okay, so let's evaluate y equals 2 raised to the negative 2. Now, of course, we have to understand, in this case, well, let's see, 2 to the negative 2, what's it mean to raise a number to a negative exponent? Now, frequently, and way too far into the course, people will still think that 2 to the negative 2 is negative 4, because it's 2 and a negative 2 gives you negative 4. That's not true. You're not following rules if you do that. The rule for negative exponent is illustrated by what happens to 2 to the negative 2. It's 1 over 2 to the second power. Now, this is something that should be very familiar to you, at least once I've said it. But I find that many people are way too fuzzy about laws of exponents, so make sure that you do understand the laws of exponents and understand the law that says that 2 to a negative, any number to a negative power is 1 over that power made positive. Okay? So this is going to be, in any case, 1/4. So we get 1/4. And at negative 1, 2 to the negative 1 would be 1 over 2 to the 1, which is just 1/2. 2 to the negative 1/2. Well, that'd be 1 over 2 to the 1/2, but what's 2 to the 1/2? Well, 2 to the 1/2 means, if you understand the laws of exponents as well as anybody should coming into the course, but again, it's not always the case that people do, 2 to the 1/2 means a square root of 2. Okay, well, do you know what the square root of 2 is? I don't. Okay, I know it's 1.414 and then a bunch of stuff, but I don't know what comes after that. If I want to take time to memorize it, I'd probably remember several more digits. It's not important. But there's no end to it. You can't calculate it by arithmetic. You go to your calculator, it'll give you 10, 12 decimal places, but that's not the square root of 2. That's just close to the square root of 2. Real close, but it's not the square root of 2. So you can't calculate this. Okay? It's an irrational number. So I'm going to say, this is a number you cannot calculate. So we're not going to include it in the table. And when you make the table for this function, you can just leave out negative 1/2, although at first I'll probably ask you to include negative 1/2 and 1/2. You cannot calculate it. Okay? Okay, 0. If x is 0, well, what's 2 to the 0? Again, something I hope I don't see much of, I hope I don't see any of it, is people say 2 to the 0 is 0. Well, that's completely wrong. One of the rules that you learn very early in algebra, as soon as you start doing exponents, actually in pre-algebra, is that any number to the 0 power is 1. Now, there's a reason for that rule, but I'm not going to digress to it right now. This is simply something that I'm a little bit shocked, isn't ingrained in people when they come into a pre-calculus course. 2 to the 0 is 1 because any number to the 0 is 1, including 0. 0 to the 0 is 1. So that's 1. Okay? You cannot calculate two to the 1/2 square root of 2. You can approximate it, but you can't calculate it. There are all one things that you can calculate. Okay? And if you know how to do square roots by, to do good approximations of square roots by hand, okay, you're welcome to do it. I knew it when I was 13 years old, but it's useless. I've forgotten it. I could probably redevelop it for basic principles, but it's useless. And nobody anymore really knows how to do that, except people that are good at remembering what they were when they were 13 years old. People my age, they remember that, because nobody much older than I am, much younger than I am, ever had to do it. Okay, so, then we have 2 to the 1. That's 2, so we're going to get a 2 here. And then we're going to have 2 to the 2nd, which is clearly 4. So, here are the values in the table. I should have, let's see what I should have done. Okay, there's a table for y equals 2 to the x. Now the basic reciprocal function, y equals 1 over x. Well, something interesting happens here. And again, there's another pitfall. By pitfalls, the pitfall here is you got to know that the square means you multiply the number by itself, and multiplying two negatives gives you a positive, and then you're pretty much home free here. Pitfall here is you can't calculate 2 to the 1/2. You can't calculate square roots unless you have integers or perfect squares, or fractions involving perfect squares in the numerator and denominator. Okay, over here the pitfall is most people don't know the laws of exponents well enough to know what 2 to the -2 means. Also, people want to go to their calculator. Keep your hands off the calculator. You never learn mathematics if you do it all into the calculator. You can't calculate 2 to the 1/2 or 2 to the -1/2. And also 2 to the 0 equals 1. So there are 3 pitfalls here. Okay, there's a pitfall over here too. So let's list the numbers. -2, -1, -1/2, 0, 1/2, 1, 2. Okay? Well, 1 over x, y equals 1 over x. So let's see. 1 over -2 is just -1/2, so we have -1/2 here. 1 over -1, well, that gives us -1. Okay, 1 over -1/2, well, it's 1 divided by -1/2. When you divide by a fraction, it's the same as multiplying by the reciprocal. So that's 1 times -2 over 1, which is -2. So we get -2 here. Now what about 0? Well, for many reasons, 1 divided by 0 is undefined. 1 divided by 0.1 is 10, because you can go 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. So you can count to 1 by 0.1s. You can't count to anything by zeros. Start, okay, I got 0, 0, 0, 0, 0, 0, 0, 0. You never get anywhere. You can't count to anything by 0. You can't divide by 0. There are other more formal reasons for that. Is undefined. Something along with the fact that 2 to the 0 equals, or any number to the 0 equals 1 should have been drilled into you by trial and error and errors that you make if you were doing mathematics with something besides a calculator. Okay, so 1 over 0 is undefined. Okay, so this is, and we'll write it here, we'll say undefined. There's much more I could say about that, but we'll say it later. Okay, then applying things very similar to what we did up here. We're going to get 2, we're going to get 1, and we're going to get 1/2. And there's a table for y equals 1 over x. For the basic function, basic reciprocal function, y equals 1 over x, at the standard basic values. Okay. Now, there are 2 other functions, but this video is getting long enough and everything comes out pretty easily at this point. So we'll split this and we'll talk about the other 2 functions and then we'll look at their graphs.